Abdullah is one of our graduates that we proudly present here. He studied economics and business administration, and he had a master's degree in applied economics from the University of Michigan, Ann Arbor, and PhD financial mathematics from the Institute of Applied Mathematics. He is a former trader employee of Turkey and currently works as a senior data science consultant and head of academics at Megamind. He has several published papers and a book, and he's also adjunct faculty at the University of Michigan, as far as I know. Please, the floor is yours.
Hello and welcome, dear distinguished guests. So it's a real honor for me to speak here because, as professors have said, I'm one of the former graduates here. Especially the previous presentation made my life easier because Dr. Alev made a great introduction about the natural language processing. So it was really helpful for me because you can think of my research as a practical application of natural language processing. Not in Turkish, but in English because, as Dr. Alev said, it's really hard to work with Turkish when it comes to NLP. So my application, my research is based on this is kind of the outline. Let me quickly go over it and then I will move forward with the motivation. First of all, after motivation and aim, I will introduce the SEC announcement. SEC is the Securities Exchange Commission. We have annually, quarterly, or sometimes unregularly reports here, in financial reports. It's really easy to extract these reports, as you know, a programming language and natural language processing. And then we apply some method like hierarchical clustering, latent replay allocation, and similarity metrics. We can extract information, valuable information out of this text. And then I will tell the data because the ultimate aim of this analysis is to apply NLP to figure out the effect on the factor model, like understanding the return, stock returns. And I will discuss the model and findings. Okay. SEC announcement, securities, this is the abbreviation for Securities Exchange Commission, as you know it. These are really important announcements because people, the companies, public companies should have annual or quarterly announcements in here. So it's all up to you to find the text, the URL, and extract the data. And there are different sections in this announcements. I will talk about it. So traditional variables have not been used in factor models, but now I will incorporate the part of the text, like topics that I extract from this text, as an additional independent variable and check if it has an exploitative power on the stock return. So some type of announcement have an impact on these returns. So this is your question, I guess. So yeah, there are some insignificant variables, this is for sure, there's no doubt about that. But there are some certain topics that we can find in the SEC announcement that have closely related to the stock returns. For instance, we will do that. If you go to the risk section and the company declaring a potential risk coming up for a reason, either very close and huge risk, that may have an impact. People can easily incorporate this information into their model, for sure. So that's why there's a lead-lag relation between the topics and the stock returns. Of course, but if you quickly capture this announcement, you can act accordingly. So that's why it's important. All right, the last part in the motivation is that I will use machine learning-based approach to get insights from this announcement. This is the crucial part, and it requires some type of expertise. And then we check the predictability of the model. So I both use the ordinary least square for understanding to run the factor model, and then apply machine learning model. So some of you I know maybe have distance with the machine learning models because it's kind of black box. But recent advancement in machine learning helps us to get rid of this black box property of this type of model. So machine learning model overperform the traditional statistical models when it comes to predictability. And predictability is quite important. If your ultimate aim is not to understand the relationship between the variables, like the independent and dependent variable, machine learning model makes our life easier because the predictive power is not even comparable with the traditional statistical model. But you have tools to explain what's going on, what's happening behind the scene. That's the crucial part of the machine learning model. So in the wrong hands, it may be a disaster. So this is okay. My aim is to improve factor modeling using SEC announcements, and I will do that using machine learning models. The other aim is to show alternative way to analyze and use SEC announcement, because now we are living in an age of alternative data. So we cannot use the same data over and over again, like the volatility, like the market capitalization, or the other variables that we frequently use in the factor model, and try and get a different result. This is not how it works. So we need to find an alternative data, and NLP provides us a strong tool to do that. Okay, introduction to security exchange commissions announcements. So the announcements are monitored in SEC starting from 2015, the risk factors. So I will focus on the risk factors only. As I said, there are different sections, but item 1A includes the risk factors in SEC announcement. So this is our focus, because risk can provide precious information. So one of the disadvantages of this type of model is this: if you try to, if you don't have prior knowledge in NLP, and if you try to compile all the text, I mean extract all the text in the SEC announcement, like the 10K, the annual announcement, and try to understand what's going on in here, there will be a noise, a lot of noise, because there are many repeated words, there are many unrelated words, something like that. But here I just focus on the risk part. Okay, 10K, thank you, 8K, and insider ownership are some of the announcements that we can find in the SEC announcements. But I will focus on 10K. As Dr. Alev said, 10K is a regular annual announcement. So 10K is a quarterly announcement, but sometimes it remains as it is. So I'm looking for a change. I need that this document change over time. Otherwise, it doesn't make sense for me to use it. So using these announcements, the 10K and 10Q are the most widely used ones. Okay. So as I said, item 1A includes the risk factor a company faces. Company discuss the potential, here in this section, item 1A, company discuss the potential business risk. This can range from risk inherent to specific industry. So there is no limit, as far as I know, there is no limit for a discussion in risk in this announcement. You can talk about the risk coming from the overall market or the specific risk that a company can face. Okay, here we go. This is where I start the empirical part. So I retrieve the 10K documents of the companies listed in S&P 500. So there may be like 505 companies in S&P 500. The name is S&P 500, but the number of companies may change depending on the situation. There will be ins and outs. So I extract only item 1A, which includes the risk factors. And I get rid of stop words, punctuations, numbers, tokenization, stemming. The thing is, these words or this bunch of words doesn't provide valuable information to us. For instance, the word risk appears a lot. So if you focus on the risk and try to use it in your model, it doesn't provide any valuable information because risk is risk. There is no value in it. Okay. So my aim is to extract topic out of this text. To do that, I use latent replay allocation. I apply this for topic extractions. So there may be several topics. Some of them may be noisy, not useful, but some of them may be helpful. You will see that. So how many topics we are going to extract? This is the crucial information here. Baltimore Data has a paper on this, and they propose like 30 topics. But it doesn't mean that when we extract 30 topics, we are done. We're good. It's not how it works. Actually, the machine learning world is changing a lot over time. So we need to keep track of this. So this is a study published in 2014. But you know, the 30 topics may provide useful information in that year, but in my case, it doesn't work this way. So after detecting insignificant topics, we can drop them to end up with a more encompassing topics using hierarchical clustering. So we start with the latent replay allocation and extract 30 topics. That we don't have labels, we just words. Like I define a, how can I say, a hyperparameter to the model, say extract me 30 topics, and then the model extract me the 30 topics. But there's no label for this. I have words for every single topic that I have. Like topic 1, it's like finance, maybe the COVID-19 pandemic. These are the most frequently used in that topic. I label them by hand. Like topic 1, I just see the words in this topic 1. I go back to the study of data, which word match with the topic, and I label it by hand. After doing this, hierarchical clustering comes in. After doing this by hand labeling, now I'm ready to move on and run hierarchical clustering as well as cosine similarity. Because hierarchical clustering helps me to, the agglomerative clustering helps me to shrink the number of the topics that I have. Initially I start with the 30 topics, but at the end of the day, I end up with like 10. So I do this using the hierarchical clustering and cosine similarity matrix. Okay, these are some of the topics that I have: regulation change, corporate management, acquisition, property, product, funding, debt risk, financial condition, and macro cycle. So this is not, we don't have 30 topics as you see that here. This is what I found when I apply hierarchical clustering using cosine similarity. I will talk about it, but cosine similarity takes two texts and then compare the similarity. If we have high score, it means that there is a high similarity between these topics, so why are you using both of them at the same time in your analysis? So drop one of them. Okay, this is the equation for the latent replay allocation. So N here, the capital N shows us the number of documents, say corpus, and then capital K shows us the number of topics we have. Capital N denotes the number of words in a document, in a specific document. So the, let me say, theta I shows us the, let me say, number of topics we have here, and phi k shows us number of words, and alpha and beta shows the Dirichlet prior weight for the topic and words respectively. So this is multinomial case. Here we see the cosine similarity. As I said, when we extract the 30 topics, we need to find the similarity because it doesn't make sense to use the similar topics at the same time in our model. In order to get rid of this problem, I apply cosine similarity, and cosine similarity of two documents will range from 0 to 1. So depending on it, I find the similarity of two different texts. Okay, the variables. Companies are listed in S&P 500 are used, all of them, for the period of 2018 and 2022, and TK 10K and item 1A is utilized to extract information about the riskiness of the companies. And a cumulative abnormal return, and question that you are familiar with this term, is used as a dependent variable. And then the exogenous variables are the logarithm of the market capitalization, book to market value, and frequency of risk topic. So the first two are the ones we are familiar with from the traditional financial applications, but the last one, the frequency of risk factor, is the new one. So we get from this analysis. Okay, this is the definition of cumulative abnormal return. So the AR shows the abnormal return. Abnormal return is obtained by the stock return minus the value-weighted market index. So I analyzed 202,500 10K announcements for this specific research. And the period that I covered is 2018 and 2022. Okay. As I said, I first run the OLS to show the difference, the traditional statistical model and the machine learning model. Actually, if you go to some of the machine learning model, you will see that OLS still is at the top of the agenda. It's intuitive and easy to interpret, and it's a white box model. So that's why some of the texts would label OLS as a machine learning model. I'm not one of them. The model is run on different window length, including 1 and 2 months. So what I'm trying to do is this. If the market is not that efficient, if the information disclosed, say in February 2022, then it may take time to incorporate for the investors or the financial analysts. So that's why, considering this fact, I just want to see what happens to the cumulative abnormal return of 1 month later and 2 months later. So that's why I use this lag to understand the impact of the topics and traditional financial variables denoted by matrix X. And Z here shows the topics. Here is the result. So in the first column, we have cumulative abnormal return for 1 month and 2 months in the second one. So what we see is this: regulation change, acquisition, debt risk, macro cycle, along with some other traditional financial variables, are statistically significant at varying significance level. When it comes to when it comes to 2 months, if we use 2 months cumulative abnormal return, the results somewhat change, but it's very similar. When it comes to machine learning, as you know that we don't have a statistical significance tool, which is one of the most important deficiency of the machine learning models, but we have predictability, and we have some tools, recently developed tools. One of them is called Shapley values. Shapley values helps us to unveil this black box property of the machine learning model, and it helps us to understand which variable contributes most to the dependent variable in the prediction part. It may not be very informative when it comes to estimation, but it works well with the prediction. So I picked the boosting algorithm because it produced the best result for me, and the variables, the topics, the important topics. I'm not quite sure if it is statistically significant in the context of boosting algorithm, but it contributes to most to the prediction part. the corporate management, debt risk, macro cycle, market capitalization, and book to market. These are the variables contribute most to the prediction part. So that's it. Thank you.
Thank you, Dr. Karasan. I mean, it was a very nice, just completing two topics to each other.
By coincidence.
So it was, if we would have planned it, we would be fitting that easily. Any questions? Yes, Zehra.
Thank you also for the very interesting talk. The window lengths of 1 and 2 months. Have you tried a bit shorter, like, I don't know, 1 week, 2 week? Because it's quite a long time for the financial market, you know?
That's correct, that's correct. So the problem with doing this is the variables that I have, the traditional variables. If I focus on this is my future research actually. If I simply focus on the topics, I can do that, like 1 week, 2 weeks, but I cannot do it using the book to market, market capitalization. That's the problem.
Okay, thank you.
Yeah, and Dr. Aksu?
So, did you use them as a frequency of them, the words that you mentioned that you put them inside of his regression? So, is it the frequency of them?
Yeah, it is frequency. Because I run it for like Apple, and then IBM, and then Microsoft, and so on. I check how many times the regulation change appears for this.
You mentioned some words which is more significant than others.
Like, I showed it somewhere.
How do you quantify that? It was in the last 2 slides.
This one?
So how do you quantify those words? Like, did you like as a frequency or?
Frequency, still frequency. I use it as a frequency in same. I just changed the model name. I just run with the OLS and then turn back to the machine learning and run the boosting algorithm.
Thank you.
You're welcome.
Thank you for the presentation. As an econometrician who is totally against the OLS model, I wonder, I'm sorry to ask, but why OLS? That's my first question. And you have a slide showing alphas and betas. How do you determine those values? That's my second question. Do you want to go one by one? I have many questions.
Okay, I may forget, so let me start. So OLS, it's a good one. So finance practitioners and finance researchers like OLS. I'm not a fan of it, but they like it. So I would like to compare the result. That's the point. And the other beauty of the OLS, as you know, is the statistical significance. When you publish a paper, they are looking for the statistical significance. And maybe it's good to see the OLS there, but when I look at the Journal of Finance, other prestigious journals, still OLS at the top.
I know, but on the other hand, there is indigeneity issue, whether you checked it, your error structures, how do they behave. You might have statistical significance, on the other hand, you might have a wrong regression over there.
Yes, yeah, you're right. So that's why I used boosting algorithm with the shaping values to see the impact of the independent variables.
Okay.
That's what.
Can you show your slide which had that multiplication with alphas and betas?
These are priors.
This one.
We need to provide that.
So how did you decide about those?
I just checked the literature and tried. Actually, it's try and see. As you know, it's empirical application. So there is no one-size-fits value for all the research. Yeah. So that's why I check and try, and if it's work, I stick to this.
Okay.
This is priors, strictly priors.
I have another question about your time period. What was the purpose of choosing that? Because you didn't explain. So
processing power. I would like to go back, further back, like 2000s maybe. Maybe it's not that correct to go further, but maybe the 10-year would be enough.
Yeah.
Or I can include more companies, but processing this takes like 4 hours for me. I don't have GPU, by the way. That's why it takes 4 hours. But if I do it for my company, it takes less and less time because we have GPU, we use cloud platform there. So if you move to this application into the cloud platform, it will take like 30 minutes or something like that. So it wouldn't be a problem to work with this data.
The reason is because it's the period mostly COVID was happening in 2018, so 19 and onwards. So I'm just wondering the reliability of your assessment from that perspective. 10K SEC Edgar data is, yes, available. I use it for my research too. I look at bank holding companies only. You have 500 companies. Perhaps a different period might give you a different answer, and I think you can compare it.
Yeah,
in a different time period.
I just want to see the COVID effect, and I saw that my research because COVID-19, this word appears a lot in the document. I would like to see that, and COVID, proposes structured break in every field, as you know. Right? So why don't I incorporate this information into my text?
But that structural break is not really reflected in OLS. So perhaps
yeah, but in boosting, we can reflect that.
you can do in the boosting part with the Shepley is fine. What is X, by the way? Do you have another slide? Is it the sectors? Perhaps I missed that. Can you go a little bit further?
Further?
You have an X variable in the OLS, I guess. Here. Sorry, I missed it.
The X variables?
Exogenous matrix.
Yes, the X variables are this, log of market capitalization and book to market value.
Okay.
The frequency of risk topics are represented by Z.
Okay.
Frequency.
And why it is running from 1 to 9 again?
This is the final number of topics that I extract from the document.
Okay, not 30, not 20.
I start with 30, then I apply hierarchical clustering, and I end up with the 9 topics.
Okay, okay.
Starting from 1, there's an indexing. In Python, indexing starts from 0, that's why it's 9 actually. It may be confusing, but it starts from 0.
Okay, alright. That's why I stopped from 1 to 9. Okay, thank you so much.
Thank you.
So, as last question from Dr. Oflas.
Dr. Karasan, thank you for your presentation. It's really nice that you emphasize that OLS model is not a machine learning model. It's really important. And I suppose it's important for us to emphasize in our articles in order not to put them to the same like machine learning group models because they have different total approach, different structure, different philosophy, like that. You use OLS because it's classical approach in your field and it's really good to compare machine learning models. However, machine learning models are black box models, that's why you use Shepley approach. Maybe it's possible to use a regression model like lasso regression, rich one or elastic map, and you may improve your prediction performance, and also that model is also white box model that might be somehow compatible with machine learning models, which is popular.
Yeah, that's a good point, but lasso and reach regressions, even though they are white box model, they have high variance, high bias, low volatility, so low variability. So the problem here is that when you use reach and lasso, they don't improve the predictive performance. These are the models that are developed to get rid of to fight with overfitting. That's the problem. So it's easy to end up with the overfitting when we use OLS. So these two models, lasso and reach, are designed for dealing with the overfitting, but they don't focus on the predictive performance. But we need predictive performance when it comes to machine learning. So the reason why I don't call OLS as machine learning, we learn something, but it's not like automatization human task. So the learning stops at some point. But when you apply deep learning or some NLP model, it just takes the control out of you and generates some very appealing results that you cannot get using simply the OLS. So they learn the estimated coefficients, that's all for the OLS. But for the other parts, as you keep feeding the model, it turns out you will start learning very interesting things from the data. This is what happens in machine learning.
Okay, so that was really a very nice discussion session. Thank you very much, both of our speakers and also participants.